So let's try to solve the famous two-car problem. So what's the two-car problem? So there are two cars that gonna meet at a junction. So we can call the cars A and B. So car A is at 200 miles west of the junction when we start timing and drives towards the junction with a speed of 30 miles per hour, while the car B is at 100 miles north of the junction and drives south with a speed of 40 miles per hour. So the car A goes to the east, and then car B goes to the south. So the question is, if that is the case, and if they are at the time at the place that mentioned when we measure time, they are still moving. They are not at stop position. They are moving. So the question is asking, find the minimum distance between the cars and the time that happens. So this question is not obvious. So we might think that they're going to meet at the junction, or the minimum distance we get at the junction. But that's not the case. We are not going to get the minimum distance at the junction. So let's see how the math works. And you can see this math is not that difficult. So first, let's see this is an animation and see how this can happen. So let's look at this one. So if you animate this motion, and this is what's exactly going to happen. And you can see that um, the car A, the red car goes to the east, and then the blue car goes to the south. And then you can see that if you look at the distance D, and it's going to start with a larger value and then it's get smaller, not at the origin. You can see it's not going to get 0 at the origin. It's going to get 0 at after 4 hours. So we can see that again, it's gonna get 0 after 4 hours, but that not gonna happen at the origin. So it will happen somewhere, like you can see the blue car has already passed the junction. The red car is still coming to the junction. So that is the situation. And so let's try to see how the math works, and we can solve this problem. So this is like a nice optimization problem that calculus students can solve. So we have two cars. One is on the west of the junction and the other one is north of the junction. Red car is moving to the east with 30 miles per hour. The blue car moves to the south with 40 miles per hour. And the red car is 200 miles west of the junction, and the blue car is 100 miles north of the junction. So let's see what happened after t hours. So t in hours, because miles per hour, so it's be easy if you do that in hours. So what we try to do, we try to find the new position after t hours. So for car A, so you can say for car A, since it is at the negative 200 position, so what happened, it says it's moving 30 miles per hour. That means every 30 mile it moves towards the east. That means the positive x direction. So that means what we need to do is for every hour you add 30. So that means it is going to be 30 times t. So that is the position of car A. So we can do something similar for car B. Car B is going to the south. So since it's going to the south, what happened every hour? It go down. So it go to the negative uh, y direction. Since the negative y direction start at 100, and then it subtract you, because you every hour you subtract 40. So it is going to be negative 40 times t. So that is the new position of car A and car B. So that's the starting position. So now what we can do is, so we can call this x and y. So I will call this is the x1 and the other one is y. So what you can do is, now you can write the distance formula for those two. So if you call the distance, so let's call the distance for this one. So let's mark it. So we're going to measure this distance. We're gonna call that d. So what we are not going to write for d, we can write actually for d squared. So let's see the argument why we can do that. Also, like you can just call LT for this one. So what is so we can write a function. So the function is, it is simply the distance equation. We know the distance formula. So we know that distance squared is simply x squared plus y squared. So we're going to plug in for that. So I'm going to call this d squared function. I'm going to call this d squared function is LT. It's a function of time. So let's call it LT. So I'm going to call this LT. So what is LT? So LT is the x squared plus y squared. So x is in this case 30t. So 30t minus 200. So we have 30t minus 200 squared plus the other one is 100 minus 40t squared. So that is the LT function. So LT is the d squared, time squared. So what we're trying to do is instead of minimizing distance, we minimize distance squared. So they have the exact same minimum values. Not the exact same minimum values, but the minimum happen at the exact same position. So now what we do, we can take the derivative because we need to find the critical point, and then you can see that here there's no the minimum time here because t can be anything. T can be going from positive infinity to negative infinity in this case. So for this problem, t can be any real number. So t is real. Because in theory, even the minimum distance may have happened earlier. So t can be negative also for this problem. So now let's use the calculus. So what we do is we can take the derivative of this one. So we can take the derivative. So this is the calculus part. So it's L prime t. If you take the derivative, what will happen? It is the chain rule. So it is 2 times 30t minus 200 square. There's no square here. Times the derivative of the inside function, which is 30. So you get 30 here. Plus the other term again 2. We have 100 minus 40t, and then we get negative 40 because this is negative now. So it is negative 40. So that's the derivative. Now what we do, since we are looking for critical points, we set this one equal to 0 because we want to find the minimum for this function, minimum of this function. So now how to simplify, and you can see first thing what we can do is we can actually cancel 2 because you divide by 2, and also we can actually divide this equation by 10. We can cancel one more 0. So once you do that, you get this equation. You're gonna get 3. Actually, you can divide by 100 because there are 2 zeros, because there is a 0 inside and there are 0 outside. So inside, outside, you can divide by 100. So once you divide by 100, you get this equation. You get 3 times 3t minus 20, and then you get minus 4 times 10 minus 4t equal 0. So that's the equation you get. What you need to do is you need to solve this one for t. So this one solve for t. Solve for t. That t value, and it's a linear equation, so there's only one t. That t value is going to give you the best value, the optimum value, in this case a minimum. So, but we can see whether this is a minimum or maximum. So let's try to do that part also. So we have this equation. So the goal is to solve for t. So what we can do is we can distribute this one. So if you distribute, you're going to get 9t minus 6t and then minus 4t and then positive 16t. So this is, you can write as, if you add them, you can get 25t equal, if you move the numbers to the other side, you get 100. So that means this says that t equal 100 divided by 25, which is 4. So that means which is 4. So that means it happened, the minimum happened. We still don't know whether there's a minimum, but this critical point is t equal 4. Now what we can do is we can look at the second derivative. So our first derivative was, so this is the first derivative we have. So let's start with one more derivative. So if you take second derivative, and you can see that you get 2 30, you get one more 30. So there are two 30s here. There's one from here and an earlier one, and plus the same thing, you can see 2 times you had a negative 40, but you have another negative 40 when you take one more derivative here. So that's a 2. So you get another negative 40, and then you can see that so you get 100, so 1800 plus 3200, and then clearly this is positive, so that means the second derivative, so by the second derivative test, and you can see that there is a minimum, there is a minimum at the critical point, So you always need to do that, because otherwise we don't know whether we have a maximum minimum. So if your question asks you to find the minimum or maximum, don't just find the critical point, because it doesn't make any sense, because it can be maximum or minimum. So you need to justify somehow, either using the first derivative test or the second derivative test, that there is a maximum minimum. So like if it's an easy one, what we normally do, we can look at the second derivative, and if it is positive, there should be a minimum, because that's what the second derivative test says. So now we know that there's a minimum at t equal 4, so we can write that as a final answer now. So let's do that. So now you can say, you can so finalize the problem. So we know that when that happens, it happened after 4 hours. So what we need to do is, now let's try to find the position after 4 hours. But if we know the positions, then we can just use simple geometry to find the minimum distance. Or you can just plug in the value into the equation, and from that you can get. So there are so many ways to do it. So I'm going to do it this way, because this is like obvious how we can do it. So for car A, so you can write the position, which is x equal, so what happened, it is 30, t equal 4 minus 200. So if you simplify, you're going to get negative 80. And similarly for car B, you can see the position is it is 100 minus 40 times 4. So if you simplify that, you get negative 60. So those are two numbers you get, negative 40, negative 80, and negative 60. So so if you if you graph it, if you draw this in a figure, so you can see this is the situation. So this is one car, this is a car A, which is at 80, so negative 80 on the left side, and then car B is at 60. So it's 60 down. So you can say negative, so negative 60. So that's car B. So what we need to do is we need to find this distance. So it's very easy to find the distance. So you can the Pythagorean identity. From that we can find the minimum distance. So you can see the minimum distance happen here at this place after t hours. So the shortest distance. So we can say shortest distance. So it is, call it S. So you can write this one as simply 1 at like 80 squared plus 60 squared because we don't put negative sign, because it's square, it's positive. So you simply get 100 miles exactly. So that means the shortest distance between two cars is 100 miles. That's the shortest it can happen. And from the animation you can see that after that what will happen, the distance gets larger after this one. So and then also you can see that this happens after 4 hours. So this happens after 4 hours. So that's how we solve the problem, and you can see it's not that difficult. It's like a nice geometry problem, and we use calculus to figure that out. So it's not an obvious problem. Okay.